Regolith mapping or landscape mapping is used to map the surface geology. This can be the current present-day surface, but can also be ancient landscape surfaces now preserved. Surface geology and landscape features are often influenced by the underlying geology. Ancient features such as faults can influence the landscape that we see. Landscape mapping is about connecting what we observe on the surface with the basement geology below.
The Gawler Craton is really one of our prime areas for exploration. Normally, the only way to find out what's below is actually drilling. The cover is there, the landscape on top of it is there. What geophysical techniques can we actually use in that setting that points us to information what the bedrock is below or what features are in the bedrock below? These structures are active for millions of years or even hundreds of millions of years. And we can actually see an expression of these large structural features on the surface. I'm looking at landscapes and the landscape surface. Patterns like sandplains, rivers and dunes, and how they are forming individual landscape areas. The basement is actually imaged in form of gravity data or magnetic data. The features I see on the surface, I compare them back to the imagery I have and create a map. And these maps we call regolith map or landscape maps. The other aspect to it is mapping linear features in the landscape. So I look at data like digital elevation models, satellite imagery, and look for lines in the data, then digitizing them manually in the software. Long lines on the surface, these can be pathways for mineralization, but also pathways for water. Often we find that vegetation or big trees follow fault lines because there's more water flowing through, they can tap their roots deeper and get down to the groundwater. For us, it's also important to actually observe the modern day processes that are happening across the landscape. Seeing rivers in flood, seeing sand moved and blown across the landscape is really important for us to understand the transport and erosion mechanism that actually led to the landforms. And now we're coming in and seeing the results, and then that's really where we then start with our mapping. We are really driven by our domain expertise. And this really allows us to actually transfer what we see in the field onto a map. But of course, everyone sees things differently, by colors, for example. My eyes will see that slightly different than someone else. And in order to get rid of this bias, we're actually now tapping into the technologies that are available via machine learning and AI. In the future, we really hope to minimize that interference of the domain expert in the mapping and classification process. Start working more on the interpretation of the data than actually creating the data. Develop models from there that help in different spaces like exploration or groundwater or energy. Companies could actually start doing more targeted surface geochemistry surveys, hopefully accelerating their rate of discovery, and then by so minimizing also their sample imprint on the surface.